Assalamualaikum and salam sejahtera. My name is Nur Farhan Shazwani. Today, I and my friend will present about electronic system. So, introduction. The electronic system is used to process electrical signals to perform tasks such as data processing, communication, control, and automation. The components of electronic system encompass a wide range of devices, which is oscillator 1, oscillator 2, active low pass filter, rectifier, voltage regulator, and load. For formation result, we are using multisim to present the output of each of block. So, functions electronic system. Oscillator to produce a period waveform on its output with only DC supply voltage as an input. Rectifier provide a full wave rectified voltage, changing the negative voltage of the AC to DC positive voltage. Active low pass filter allow frequency below the critical frequency to pass and reject other. Voltage regulator keep the output constant under all operating conditions. Okay, next we go to design and simulate for oscillator 1. So, for calculation, number 1, assume C equal to 1 nanofarad. So, C equal to C1 equal to C2 equal to 1 nanofarad. Number 2, find the value of resistor by using formula and the frequency. So, R equal to 1 per 2 pi Fc. So, we get 159 kilo ohm. So, R1 equal to R2 equal to R equal to 150 kilo ohm. Number 3, we calculate the frequency which calculated value of R and C to check whether it met the specification. So, frequency resonance equal to 1 per 2 pi Fc and we get 1 kHz. Number 4, use Young formula to calculate Rs and Rf. So, AV equal to 1 plus Rf Rs. So, 3 equal to 1 plus Rf per Rs. 2 equal to Rf per Rs and we get 2 Rs equal Rf. That Rs equal to 30 kilo ohm and Rf equal to 62 kilo ohm. Okay, noted. The gain of each oscillator must be around 3 so that the oscillation to be sustained. If the gain is less than 3, the oscillation will fizzle out. If the oscillation is more than 3, the oscillation will produce distortion. This is simulation. And this is the output for sine wave. And we get frequency 1 kHz and we pick 1.4 volts. That's all for me.
Assalamualaikum and salam sejahtera. My name is Muhammad Arif bin Abdullah and I will continue our presenting with the second oscillator. The oscillator type is the Weinberg oscillator and the resonance frequency or Fr is equal to 20 kHz. First, we do the manual calculation. First, we assume the C or capacitor is equal to 3 nanofarad. The capacitor value is same for the board C1 and the C2. Second, we find the resistor value by using the formula and the given frequency. Using formula, R equal to 1 over 2 pi Fc with the F is equal to frequency and C is equal to capacitor. By replacing the F and C with the 20k Hz for the frequency and 3 nanofarad for the capacitor, we will get the value of R is equal to 2.65 k ohm. Third, we recalculate the frequency with the calculation value of R resistor and the C capacitor to check whether it match the spec. The given frequency is Fr is equal to 1 over 2 pi RC with the R resistor and C the capacitor. By replacing the R value with the 2.5 kHz and C value with the 3 nanofarad, we will get the Fr, the resonant frequency, is equal to 21.2 kHz. Fourth, we use the gain formula to calculate the RS and RF. Giving formula, AV is equal 1 plus RF over RS. AV is equal to 3, that means RS over RS is equal to 2. So, 2RS is equal to RF. If the RS is equal to 40k ohm, RF is equal to 2 times 40k ohm equal with 80k ohm. Next, we do the part simulation in the multisim. The value of R1 and R2 is equal to 2.25k ohm. C1 and C2 is 3 nanofarad. RS is equal to 40k ohm and RF is equal to 82k ohm. We use diode D1 and D2. The operational amplifier or OM we use is the 741 IC. We supply 50 volt VCC and negative 50 volt VEE. We get the result using the oscillator. The graph that we get is the simultaneous wave. The amplitude is 50-100 millivolt and the time is 50 microsecond. The frequency is 21 kHz and the peak to peak is 1.32 volt. Okay, that's all for me.
Very good afternoon. My name is Navinesh Meghnadhan. So today I'm going to talk about the summer rectifier circuit. So the purpose of this circuit is basically to combine voltage of many input. So the input voltage to one output voltage. So in this case, which is 2 input from output for Wien bridge oscillator. So now we are going to moving to the calculation. So first one is RF over RS is equal to 1k ohm. So the R1 and R2 represented as R9 and R10 as, and the value is 1k ohm respectively. So the voltage output, so the formula is RF plus bracket V1 over R1 plus V2 over R2. So the RF value is 1k ohm. So the R1 and R2 will be the same one. So the V1 is 687 millivolt and the V2 is 665 millivolt. So when the calculation is, so the 1k ohm will be the cut one. So rest is 687 millivolt plus 665 millivolt. So the voltage output for the answer is 1.355 volt. So now we go into the simulation. So this is the oscillator one circuit. So this one is the oscillator circuit. So this one is the summer rectifier circuit. So the first channel 1 is the oscillator 1, the frequency is 1 kilohertz. So the channel 2 is 20 kilohertz and the channel 3 is, for this one, summer, is the 16.6 kilohertz. So the channel 3, so the voltage is peak to peak is 2.66 volt. So will be 2 divided by 2, so we will be get 1.3 something voltage. So this is the simulation and the circuit. So that's all from me. Now we are going to move to the active LPF.
Hi, my name is Kumaran Krishnan and today I will explain about my circuit which is active low pass filter. So for this circuit, the circuit type is second order quarter response. Okay, you can see for this calculation, for this value for RA between RB is 0.586, which we can see in this table. Okay, this table the ratio for R1 and R2 for two poles is 0.586 to find the resistor value because this circuit is second order. Okay, as you can see the calculated values, which I assume the RA is 586 ohms. Then put the values in equation and we get the RB value which is 1 kilo ohm. Okay. Then for this circuit, the value of capacitor must be less than 1 microfarad. I assume the C is 0.1 microfarad. After we get the value of C, we just use this value in this equation FC equals to 1 over 2 pi RC. Then I change the R as subject to find the resistor value in the circuit. Then we put the value which is FC, the cutoff frequency is 8 kHz, which is given, and I assume the capacitor 0.1 microfarad. Then we calculate, we get the R198.94 ohms. So from this value I calculated, which given, I completed the circuit active low pass filter. Okay, when I run the simulation, I use plot butter as my output. So for this, I just find the magnitude for cutoff frequency, which is 8 kilohertz. Okay, this will be my magnitude for my cutoff frequency, which is 0.84 dB, and the output for peak to peak voltage of my circuit will be 1.23 volt. Then my output frequency will be 14.2 kilohertz. Okay, that's all from my today. Thank you.
Okay, so good morning to everyone and also Foster. My part in this mini project is rectifier. So today I would like to explain about the part of rectifier. So that is a full bridge rectifier. So first I explain about the full bridge rectifier. A rectifier converts an AC signal to DC, and a bridge rectifier does this using a diode bridge. A diode bridge is a system of 4 or more diodes in bridge circuit configuration. So here we can see about my calculation. So first, capacitor we assume as 1 microfarad. Then this is a calculation. Take VP peak to peak from the output of LPF that we can see before this slide. So that is we get peak to peak value 1.23 at active low pass filter. So we take the peak value, so we need to divide the 1.23 with 2, then we can get 0.615 volt. So this calculation we're doing for find the VRMS. So VRMS is the formula is 0.707 times VP. So peak value we already get 0.615, so we can state times with that, so then we can get 0.434. So after that we can see the circuit. So here we can see we use the VRMS value 0.434 that we get from the calculation. Then we get the rectifier one, then full bridge rectifier, then capacitor value we already say, right, we use 1 microfarad. So then R1 also we assume as 1 kilo ohm, so then we get the output like this. So here we can see the frequency 14.2 kilohertz. Then with peak to peak is 613 millivolt. You can see the simulation for rectifier. that is a full bridge rectifier. So this is the waveform for full bridge rectifier. Here we can see the peak-to-peak value, that is 43.9 microvolt. Then frequency is 28.4 kilohertz. Then I go for my next part. So my next part is voltage regulator. So I first explain about the voltage regulator. A voltage regulator is a circuit that creates and maintains a fixed output voltage, irrespective of changes to the input voltage or load conditions. So here we can see the calculation that I do for my circuit. So R1 we assume as 1 kilo ohm. Vz is Zener diode. Then R2 equals to R3 equals to 20. That means R2 and R3 we assume as 20 kilo ohm. Then Vb is 0.7 equals to 0.7. So we use this formula to find the Vz. So Vr equals to 1 plus R2 over R3 times with Vz. So then we simplify this, means we get 2 Vz equals to Vout we put 5. So then we can get Vz as 2.5 volt. So that is in a diode. And then the input of the OPMP shunt regulator circuit is continuous from the output of rectifier that we see before this. So this is the circuit of voltage rectifier. So sorry, voltage regulator. So we can see here the circuit. So in circuit we use this is the Vz Zener diode. So we use 2.5, that calculation value. Then R1 just now I said already 1 kilo ohm USMS. Then voltage regulator. Then we got R2 and R3. So we assume as 20 kilo ohm just now. Then R4 we assume as 25 kilo ohm. 25 ohm. So then after that we can get the so this is the output. We can get 4.917. that we get 5 volt. So just now at calculation also we use the 5 volt. So here also we get ready 4.917 volt.
Okay, hi everyone. My name is Yudesh Kumar. Okay, I will explain about load. Okay, if you see, this is the calculation. So the given P load required is 1 volt. Voltage load is 4.917 volt, which is the voltage regulator. And power load formula is voltage load square over resistor load, while resistor load is voltage load square over power load. So 4.917 square over 1 volt will get 24.18 ohms. Okay, if you see, this is the simulation for resistor load. Okay, V1 is 4.917 volt, which is the voltage regulator, and R1 is 24.18 ohms. So in the simulation the light is on, which is 5 volt. Okay, next if you see, this is the overall simulation. So this is the overall simulation, which is start from the oscillator 1, oscillator 2, and active LPF and rectifier, voltage regulator, and finally the load. So this is the overall simulation combined, which is combined of oscillator 1, oscillator 2, active LPF, rectifier, voltage regulator, and load. Okay, that's all from me. Thank you.
B0822100046. Today I will talk about the discussion of this project. In this project, we have assembled a various components into an electric electrical circuit system, including two oscillator, an active low-pass filter, a rectifier, a voltage regulator, and a load. The chosen oscillator, the Wien bridge oscillator, produces a sinusoidal waveform and is constructed using resistor capacitor and NOM. The active low-pass filter implemented as a second-order Butterworth response. The Butterworth response allows low-frequency signal to pass while alternating higher frequency. The rectifier uses a full bridge configuration, which diode to convert AC input to a smooth DC output. A voltage regulator is implemented using NOM shunt regulator circuit to maintain a stable output voltage by diverting excess current. Finally, the load is connected to the circuit and care is taken to meet its requirement and a secure proper power supply. Through the project, we face challenge related to interference and noise, stability and feedback, frequency and gain interaction, power supply consideration, and load compatibility. Interference and noise can be minimized through circuit layout design, shade technique, and grounding. Stability and feedback are critical for proper oscillator functioning, requiring careful attention to feedback patch and phase relationship. Frequency and gain interaction between components should be analyzed to achieve desired functionality. Power supply consideration to secure stable DC power and prevent overloading and voltage malfunction. Lastly, the load specification must be met through load balancing, impedance matching, and power supply adjustment. Then I will talk about the conclusion of this project. In conclusion, our project successfully implemented the circuit according to the given specification. Through the process, we gain valuable knowledge and experience in construction the circuit and performing the necessary calculation for each component, including the oscillator, active low-pass filter, rectifier, voltage regulator, and a load. We now have a comprehensive understanding of the function and operation of each block within the circuit. The project has significantly enhanced our practical skill in circuit design and implementation, providing us with the confidence to apply this knowledge to the future project and have us in field of electrical engineering. That's all from me. Thank you.